Colby, math.com.
Today we began a unit on algebraic reasoning, and we did some proofs, constructed some proofs to not only identify variable values, but justify each step of the solution by citing the properties we used. And this is why you only have 6 algebraic equations to solve on tonight's assignment. The assignment is not solving for the value of x nearly as much as it is citing the steps along the way and getting to understand these different algebraic properties and the names of them. I won't make you do a full proof on the exam at the end of the unit, but I certainly will expect you to know or give an example of multiplicative inverse or additive identity, and so the best way to learn those properties is to do this the right way. I also told you in class that in order to do this assignment properly, you need to cite the properties, and that is the assignment. Identifying the value of x is not the assignment. So if you do not cite the properties on your assignment by following your notes and or this video, I will not accept the assignment until you do so. That always happens with a few students every year. Just give them another chance to do it again, but hopefully we can get it right on the first try. If I can isolate x on one side of this equation, then I'll know what x is equal to, and I will have identified x. And so we're going to ultimately use one of the identity properties, but we need to first, remove things like this constant term and this coefficient. And the way we do that is we start with the constant term of 15 and we subtract 15 from both sides of this equation. You can think of the equation as a balance scale, like we said in class today, if it helps you to draw that line. Just to think of the two sides of the equation, you can. Some students like that, some students don't. But in either case, when we're doing the same thing on both sides of the equation, that's the property of equality. You can do anything you want to one side of the equation as long as you do the same thing to the other side. And we did that because 15 minus 15, of course, is 0. And if we can make the constant term 0, we can get rid of it and simplify the left side of the equation, the side with the variable. And 39 minus 15 is 24. Now the property that we just used and the reason we chose to subtract 15 is the additive inverse. You can undo addition with subtraction, you can undo subtraction with addition. Addition and subtraction are inverse operations. So 15 minus 15 is 0, or 15 plus negative 15 is 0. If you add opposites, you get a sum of 0. That's an example of the additive inverse. The fact that 2/3 x plus 0 is 2/3 x is the additive identity. If you're adding 0, you've identified the other term. In other words, you can add 0 to anything without changing its identity. That's the additive identity. Now, we have 2/3 x equals 24, but I don't want to know what 2/3 of x is. I want to know what x is. And x is 1x. And I can change this coefficient to 1 if I simply multiply it by its reciprocal. The reciprocal of 2/3 is 3/2. Of course, if I multiply the left side of my equation by 3/2, I need to multiply the right side of my equation by 3/2. That's the property of equality, doing the same thing to both sides of the equation. Three halves of 2/3 is 6/6, or you could think about the fact that these become 1 and these become 1, and you get 1x. 6/6x is 1x. And on the left side of the equation, well, half of 24 is 12, and 3/12 is 36. But the fact that reciprocals multiply to give you a product of 1, that's the multiplicative inverse. And the fact that 1x is the multiplicative identity. The same way that you can add 0 to something without changing its identity, you can multiply something by 1 without changing its identity. That's the multiplicative identity. You use that every time you multiply fractions by, like for example, by 2/2 or 5/5. In order to get a common denominator, you're using the multiplicative identity. Now I'm not going to circle that solution for x because I haven't yet verified it. Now we're going to use a substitution property and substitute that value for x. If x is 36, I should be able to substitute 36 into this original equation, and I should find out that the left side of the equation, once I simplify it down, is actually 39. Do that during the pause and then come back and see how you did.
Paused.
All we do is we rewrite the equation, but when we get to x, we substitute the value that we found for x, which is 36. Two-thirds of 36 is 24 because a third of 36 is 12 and 2/12 is 24. I forgot to write my property here. I substituted x for its equivalent value or its identity, and that's substitution. Anytime you substitute an expression for its equivalent value, you're using the substitution property. In the same way, when I multiplied 2/3 by 36, the product of 2/3 and 36 is 24. So I substituted this multiplication expression for its value. That's also substitution. Now I know everyone can add 24 and 15 in their head, but I'm just trying to make a point. Let's say it was something we couldn't add in our head. You should actually add them on the side. Make sure you really do get 39. Because too often students will make a mistake over here on this side, and then they'll substitute their incorrect value in, but they won't actually do the operations. They'll just write whatever this is, this equals this, and check it. But if you do that, you miss the opportunity to catch a mistake. If when we multiplied 36 by 2/3, we get something other than 24, when we add it to 15, we'll find out that our value does not equal 39. That's not a bad thing. That's a chance to go fix your mistake. That's a chance to get the problem right. But when we actually do all the computation and we do get 39 equals 39, it's like 39 is looking in the mirror at its reflection. That's the reflexive property. And that's when you can circle your variable value because you know you got it right. Thank you for taking time to watch the video. I'll see you tomorrow.